Good morning. This is Mr. Eicher, and I am not here right now, even though you're hearing my voice. Because of the joys and discoveries of technology, I can be with you in spirit and in word, but not presently. I think there's a spiritual application here. Christ has left us his word, but we can't see him, but we can hear his voice in the word that he's left us. And with that, I should remind you, it's Jacob's turn to pray today. So if you'd like to pause this video, Jacob can begin class with a prayer from 1 Thessalonians 5. And if he doesn't have it, shame, shame, shame. But thankfully Romans 8 says there's no condemnation for those in Christ. So pause this video if someone will open class with prayer. So let's begin. The substitute will pass out, or has already passed out, the class notes that look like this. Chapter 10. We only have 2 more chapters after this one. Congratulations. Chapter 10 is really similar to the previous chapter 9. All that we now have 2 populations, or 2 groups, that we'll be comparing in this chapter. So you notice your homework, and today's Friday. So let's begin. So section 1, sampling distributions of a difference between 2 proportions. In the previous chapter, we would have one sample, one proportion. Sample size was n, p hat is the statistic, and the parameter is p. In this chapter, we're incorporating a second sample. So we have p sub 2 is the second parameter, p hat sub 2 is the second statistic, and n sub 2 is the second sample size. Now there's a lot of information in the next box, might look intimidating, but you've actually learned all of it before. So some of it actually might look familiar. Sampling distribution, the shape is normal as long as n1 p1 and n1 1 minus p1 are both at least 10. You've seen that before. The only new thing, now that we have 2 samples, we have n2 p2, kind of like r2 d2. But n2 p2 and n2 1 minus p2, the number in the sample times failure. All 4 have to be at least 10. Then the sampling distribution is approximately normal. In other words, this is the stuff you'd want to memorize. In the previous chapter, you would do this and this. All that we're adding is the second sample. You have to test that as well. The center, the mean of the sampling distribution is P1 minus P2. That is, the difference in the sample proportions is an unbiased estimator of the difference in the population proportions. For measure of spread, the standard deviation of the sampling distribution is, or sampling distribution of P hat 1 minus P hat 2 is the square root of, now if you look at this formula, you've seen the first part of the formula before. N1, the square root of P1 times 1 minus P1 over n. All that we're doing now is adding a second standard deviation. So I'd like you to memorize that. So let's look at an example. Who does more homework? Suppose that there are 2 large high schools, each with more than 2,000 students in a certain town. At school 1, 70% of students did their homework last night. Only 50% of students at school 2 did their homework last night. The counselor at school 1 takes an SRS of 100 students and records the proportion, p hat 1, with that did homework. School 2's counselor takes an SRS of 200 students and records the proportion, p hat 2, that did the homework. So let's just practice checking conditions. So to check conditions, the random condition is probably the easiest one to check, which is really nice. So the random condition, we were told in the problem that they are simple random samples. So better change that. School 1 was a SRS, so that's good. And then school 2 was a SRS. So they're both from random samples. If they're not from random samples, then it's really pointless. And we don't want pointlessness. This isn't Ecclesiastes or anything. To check the normal condition, At school 1, 70% of students did their homework, so we'd have 70% times the number of students at school 1, which was, the SRS. The number in the sample was 100 students at school 1. And that has to be greater than or equal to 10. And then the percent failure would be 30% times 100. That has to be greater than or equal to 10. And both of those are true. So all of this information was from school 1. School 1. So we can assume that it's approximately, the sampling distribution is approximately normal for that. And then next, for school 2, we have 50% at school 2. So this would be 50% times the number in the sample. 50% number in the sample was 200, and that's greater than or equal to 10. That's true. And then 50%, 1 minus 50 is 50, so that's greater than or equal to 10. So school 2, we can assume that the sampling distribution is approximately normal. Lastly, the independent condition. The independent condition, we can say two different things. Number one, I think it's fair to assume, but maybe not, maybe people would argue. We assume the individuals at school 1 are independent. Now, some people might argue that, I didn't do my homework last night because I was talking to a student at Granite Hills. So that would be a problem, that it wasn't independent, that me not doing my homework was dependent on an individual at another school. But I think it's fair to say that if you're concerned about that, then you could always do the n. It has to be less than or equal to 1/10 of capital N. And if you notice, both schools had 2,000 students. And with 2,000 students, one sample was 100, so that's less than 10%. And the other had 200, which is right on the line, but both of them are fine. So the independent conditions are fine. Moving right along. Confidence intervals. Looks like an incredibly long formula, and I guess in some ways it is. But confidence intervals for the difference between two proportions. It's called a two-sample. Last chapter we did one-sample z intervals. This is a two-sample z interval for a difference between proportions. When those three conditions are met, random, normal, and independent, you get this nasty long formula, which I do want you to memorize. But it's really similar to the previous formula. The previous formula only had a p hat. Oh, I gotcha. P hat, a little highlighter there. It had a plus or minus z, and then it had all of this in here. All that we're adding is, this is going to get really messy. This is probably dangerous to do. All that we're really adding is this part and this part. Check that out. I never did that before other than on an iPad. So memorizing the formula, now that you can't even read it, you should memorize that formula. On the calculator, show you where it is. Erase all that stuff. On the calculator, it would be under Stat, over to Tests, and we have their proportion, so it's a prop, not 2samp, but 2prop. So let's see, we got 2samp, those are for later. This one right here, 2prop z int. So two proportions, it's z for proportions, and it's an interval for int. So that's what we're going to be using when the time comes. And it's letter B on my calculator. The calculator asks for x sub 1, x sub 2, which stand for number of successes. If you're given a percent, then you need to calculate the number of successes, rounded to the nearest whole number. And we'll see that a little later. To find z star, which is part of the formula right here, z star next to the square root. To find z star, you can use inverse norm of the area, and remember you have to add part of the tail, and that's under second vars. I'll remind you of that soon. And there you go. Area for a 95% interval would be 95 plus tail, which would be 97.5. So let's consider how to make a confidence interval. Many news organizations conduct polls asking adults in the United States if they approve of the job that the president's doing. How did President Obama's approval rating change from August 2009 to September 2010? Now, if you'd like to pause this video and read my footnote, you can pause the video now. Okay, so we have, according to a CNN poll, 1024 randomly selected U.S. adults on that date. 50% approved Obama's job performance. So there's going to be a lot of numbers in these word problems. The first sample was in September 2010, so we'll make our n sub 1 1024, and our p hat sample proportion from our first sample is 50%, so keep that in mind. CNN poll of 1010, this is from our second sample, so this would be n sub 2. Randomly selected U.S. adults, 53%. So this is our p hat 2. So now we're going to check the normal condition, keeping all that in mind. Check the normal condition. Normal condition's the long one. We'll assume that the random and independent conditions are met. So our normal condition would be, let's see, that N1, P1 has to be greater than or equal to 10. So N1 was 1024 times P1 is 50%. And I think we can all agree that that is true. If you want to disagree with me, I'm not there, so I'm not going to answer your question. 1024. 1 minus 50% is, whoops, that should be a minus 50%. We can agree that that's also greater than or equal to 10. So the sampling distribution is approximately normal for the first sample. Second sample, N2, P2 is greater than or equal to 10. N2 was 1010, and times 53, greater than or equal to 10. That's good. And then 1010, 1 minus 53% would be 47%, greater than or equal to 10. And that's good. So we can assume that the sampling distribution is normal. So moving right along, we'll make a confidence interval now. Use the results of these polls to construct and interpret a 90% confidence interval for the change in Obama's approval rating. So this is actually a really common thing to hear on the news. People will say, a year ago at this time, the president's approval rating was 50%, and now the approval rating is 52%. So therefore, people like the job that President Obama is doing, or something like that. So in this case, we want to find the change in Rommel? Oh, no, not him. Obama's approval rating among all U.S. adults. So to find 90% confidence interval, you need a z star. So if you remember this formula right in here, the z star right in the middle there, we can find that, and I gave you directions right here how to find that. So z star in this case would equal 1.6449. And where did I get that? Well, if you let me erase that, z star is 1.6449. Erase that, go over here to the calculator. If you go to vars, actually second vars, number 3, inverse norm, and you put 90%, but you have to add one of the tails. You have 10% left over, so half of that's 5%, and you get 1.6449. You can round it to 1.64 if you'd like, Or if you're Miss Williamson junkie, you could round it to 3 decimal places, 1.645. So that's how we got that. For the actual confidence interval, we would have 50% of the first sample was 50%, so we have to find a difference. 50% minus 53% of 1010. 53% of 1010 is 0.5297. You could round it to 2 decimal places if you'd like. So that's the difference. Plus or minus that z star that I found, which I'll just round to 2 places, 1.64. Times the square root, and this gets incredibly long. Set it up here. So our first sample had 1024 people in it. Our second sample had 1010. And our first success, 50%, liked the job the president was doing, so that would be 50% right here. And 50% right here. And it's a plus. And then the other group was 53%. Times failure, which is 47%. And calculating that, I'm going to be erasing this soon, but calculating that, we would, okay, I'm going to erase it. I'm going to erase it. You ready? You ready? Bam. So calculating that on our calculator, it would look like this. Under Stat, we'd go over to Tests, and we're going to go down to 2prop z int, letter B. Hit Enter. Now, x sub 1 is the number of successes. So we had 50% of 1024, which you could do in your head, but oftentimes you can't, so I'll show you what it looks like. That's rounded to 512. That's delightful. N1 was our first sample, 1024. X2, 53%, like how the president was doing, out of a sample of 1010. Bum, 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 bum. Bum, 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 bum. Bum, 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 bum. 535.3. Has to be rounded to a whole number, 535. You don't want the decimal in there. And this is 1010. And calculate nicely. Put 90% confidence interval. Calculate. And you get this answer, which we'll round to 2 decimal places, I guess. So that would be negative, come over here and write that. We'd have our answer is confidence interval negative 0.06, comma, 0.01. 0.01. So that's our answer. So the difference between the two proportions, the two samples about how the president is doing, the difference, we can be 90% confident, this is the interpretation of the interval, we can be 90% confident that the actual difference between how people viewed President Obama in 2010, I think it was, and how they viewed his job in 2009, we can be 90% confident that that difference in proportions is captured by this interval, negative 0.06, comma 0.01. On the next question, we're asked, based on your interval, is there convincing evidence that Obama's job approval rating has changed? So if you think of the hypotheses, if his job approval rating has not changed, if you think of the null hypothesis, if it has not changed, then the difference between the two proportions, if P1 and P2 are the same, there's no change, that would equal 0. The alternative hypothesis would be if it's just changed. We don't know if it's gotten better or worse, so it's two-sided, not equal to 0. If you consider the confidence interval that we just made, our confidence interval was this number, negative 0.06, comma 0.01. Notice that our difference in proportions, mu, right here, that it is included inside this interval. So we could be 90% sure that there is not enough evidence, I should say. We could be 90% sure that there's not enough evidence to conclude that there's a change in his job approval rating. So let me write that down. We can be 90% confident. Sorry, my writing isn't very nice, but then again, I guess it never is. We can be 90% confident that there's little evidence, or that there's no evidence, little evidence for a change. And Obama's rating. And the reason is our null hypothesis has been captured by the interval. So I guess if we step back and consider why the change in 2010, it was 50%. 2009, it was 53%. So just based on the percentages, it looks like, 2009 was 53%. 2010 was 50%. Just looking at the numbers, you might say, oh, people dislike Obama now by, 3%. So why the change? If we said there's little evidence that there is a change, well, just sampling variability. We take a sample because we can't ask everyone in the United States their views. So there's going to be, plus or minus margins of error for both samples. So since, even though there's a 3% drop in his approval rating, everyone in the United States wasn't asked, so there's always going to be sampling variability. So based on this sample, there's not enough evidence to say that there's been a change in his job approval rating. And let's read the last example. Are teens or adults more likely to go online daily? The Pew Internet and American Life Project asked a random sample of 800 teens and a separate random sample of 2,253 adults how often they use the internet. Sorry about that. I'll just emendate the notes. Save that. In these two surveys, 63% of teens, 68% of adults said that they go online every day. Construct and interpret a 95% confidence interval for the difference between the two sample proportions. And you're welcome. Assume the conditions are met. That's really nice. So if the substitute will pause this video, or if you'd like to pause this video, first try to identify what N1 and P1, N2, and P2 are. So I hope that you found that N1 is number of teens, P1 is the percent of teens who go online every day, N2 was number of adults, and P2 is the percent of adults. So now see if you can plug these numbers into the formula, make a 95% confidence interval for the difference of the proportions. And please pause this video. The answer you should get is negative 0.0886, comma negative 0.0114. If you have questions, I'm sure someone in class was able to get that answer. Your Z star.
Josiah Harrison, please come to the office. Josiah Harrison, please come to the office. Thank you.
Z star was 1.96. That was Mr. Wilkins. And make sure you interpret. We are 95% confident that the interval that we have here actually captures the true difference in proportions of teens to adults. Thank you very much. Enjoy doing your homework.